Another way we can combine things is as an alternation or a selection or an OR. So last week we took a look at all strings beginning with 101 or with 110. First time we tried something other than 101. So last week we wound up with a couple variations on that, but this was one of them. And to get to this, we had to sort of look at what the strings we were choosing between 101 and 110, what they shared in common. Because the in common part stayed along a branch, and then we had to split apart after that. Well, again, there's sort of a way to do this with non-determinism, which I think is easier. And if you don't agree it's easier, you will probably, I think, after you've seen a few of these, have to agree that it does have the advantage it's more readable, because it is so idiomatic that when you see it, you immediately know what's going on here is an OR. And the way this works for non-deterministic machines is to simply take the two strings that you want to recognize, so here's 1, 0, 1. So this would be the recognize 101 machine, and then we'll do another machine to recognize 110. 1, 1, 0. And in that machine, this would be our initial state. And this would be final. So we now have two machines that recognize our two alternative strings. Yeah, okay, slide. That's not a good idea. So let me pull you down a bit and grab these and move them a bit more into the middle. Now to combine these, we can again use epsilon transitions. And what we do is we join the two initial states to a common starting state. And we join them via epsilon transitions. Which says if I come here, I'm ready to start looking for either 101 or 110. The epsilon transitions start me non-deterministically along two paths, one searching for 101, the other searching for 110. And we take what had been our final states and we join them together to a common new final state, also by epsilon transitions. And actually we could leave those final if we wanted, but it makes more sense to mark that as our final state. So now we're going to start at Q14. So that becomes our new initial state. And look at what we've got. From the start, we will say, I can look here or there. One of these searches for one string, 101. The other searches for the other string, 110. If we find either one, we say we're good. And we immediately transition to the accepting state. So let's try running that. And I'm just going to get rid of some of these others. And let's see that if I give this, let's say 0, 0, 0, I start in the initial state, and notice I immediately start in Q6 and Q10 as well, because those are joined by epsilon transitions. Upon seeing the input 0, well, nowhere to go from any of those. And so I immediately fail. All right, that was spectacularly uninteresting. But it's good to know that it fails. If I see 101, I start in Q14, Q6, and Q10 simultaneously because of the epsilon transitions. Upon seeing the first one, I will move from Q6 to Q7, from Q10 to Q11. And so now I am simultaneously in Q7 and Q11. Not sure why I'm being shown as still in Q14. I don't think I should be. And it's certainly not triggering the other states there. Oh, okay, it's showing that Q14 did not have a transition there, so it's showing that in red. So that will disappear on the next click. Now our next input is 0. On 0, Q7 takes us to Q8. Q11 has nowhere to go. And so Q11 fails on that input. Q8 is still happy, however, and when we see the next one, it moves us to Q9, which immediately triggers Q15 via the epsilon transition, and we accept. I can exercise the bottom half of that automaton by stepping through 100. And so again, I start in Q14, Q6, and Q10 simultaneously. Stepping forward on the 1, I will again reach Q7 and Q11, but Q14 is going to fail. On the next 0, Q7 will... No, I didn't do the input I wanted. That's okay, we'll do this anyway. I meant to do 110 and I typed in 100. So, but that's okay, we'll do this. On a 0, Q7 moves forward into Q8, Q11 fails, and now on a further 0, Q8 will fail as well, because 100 wasn't either of the strings we wanted. Now let's do 110. And again, we start in those three states to start with. On the 1, we make the transition into both Q7 and Q11. Q14 will fail. On the next one, Q11 will transition Q12 and Q7 will fail. On the next 0, Q12 gets to run forward to Q13. Q7 has failed, so it doesn't get to go anywhere. And from Q13, we immediately trigger Q15 and accept. And so it appears to work. So that pattern of seeing a common starting state tacked on and then going off with a bunch of epsilon transitions and then being gathered again is very reminiscent of sort of an if-then-else in a programming language, where you basically say from a common starting point, the if, I can branch to one of two places, each of them proceeds in its own sequence, and then they gather in again together at the end if. And so visually, I look at this and I immediately know what's going on, whereas if I look at the deterministic version, I have to think about it just a little bit more.